All right, hey guys, Miss G here. Going to talk about some triangle similarity. First off, just to let you know, do this a little differently. Obviously, you can tell that. I'm going to use a Jamboard for this one. So in case you're wondering where Jamboard came from, you have access to it on your Google Drive. So if you open up your Google Drive, go to that little new thing, or I think it says create actually. Click the plus sign. You'll see where it says document, Google Slide. Click the more button, and as you scroll down, you'll see something called a Jamboard. So it's just like a whiteboard that you can use to write on with your stylus if you have one. Obviously you can use your mouse as well. You don't have to have a stylus. It's just easier with a stylus. So if you haven't already turned in your presentation that was due actually today, well, this is Monday, but you'll be seeing this on Tuesday. So due Tuesday, April 28th. April 28th. You could use a Jamboard if you would like. What we're doing with this week's lesson, which I've already talked about in the welcome, introduction video, is that we're going to use those theorems that you learned from last week and put them to use in deciding if triangles are congruent and are similar. The importance in learning that the similarity ones is the ratios, because ratios are not going away. Even if you are a math major, you go all the way up to Calc 4, it's still there. And it's definitely an important part in your grown-up life. Your parents probably aren't going to say, oh, yeah, I use it all the time, but they actually do. They just don't realize it's ratios and proportions. So the first thing that we're going to do with this triangle similarity is just talk about those theorems first that were definitely used for similarity. So the first easiest one that we have is angle, angle. So angle works when you have at least two angles that are showing congruent in a triangle. I don't like that marker. It's weird. So two angles in a triangle are congruent. It works because of the triangle angle sum theorem. We know that if you have two angles that are congruent, or two angles, if we have two angles in a triangle, we can figure out that third angle because all of those angles have to add up to 180. So remember, this symbolizes similarity. There's the symbol right there. I drew it in blue. Doesn't mean that these two triangles are congruent, but it does mean if you have at least two angles that they are similar. Another easy one that we have is side, side, side. So in looking at two triangles, if the sides are proportional, so I don't want to mark that they're congruent because I don't want you to think that we're saying these two triangles are congruent, while side, side, side does work for congruency as well. So if all of the sides are proportional, let's say this is 3, this is 2, 3, 4. So I'm going to multiply all the sides by 2, which makes them proportional. So these two triangles are similar because each side is proportional, right? 2 goes to 4 by multiplying by 2. 3 goes to 6 by multiplying by 2. 4 goes to 8 by multiplying by 2. And I'll show that later on. Another one that we can use would be angle, side. I'm not really going to draw. Well, yeah, well, sure, I'll draw it. So angle, side is when you have an angle. Oh, I just drew a side, didn't I? Whoops. My bad. That's not the eraser this is. Okay. So when you have an angle, an angle, and then a proportional side. So notice that the sides are not equal. They're proportional, 3 to 6. That one's kind of hard to tell. But we don't really need the extra side because, again, we already had angle. And if you have angle, that already proves similarity. But angle, side will work. Just like if you had angle, side, angle. Okay, angle, side, angle would work as well. But again, you already have the two angles, so you didn't really need to see the side. So basically the one that we have that really is strictly for similarity is angle. The other ones that we can use. Side, side, side is our biggest one that we're going to use in trying to say that two triangles are similar. So let's go on to some examples that I have. I need the pointer to go to the next screen. Oh, I'm getting it, guys. I'm getting it. Okay, so here we have our two triangles right here. As you can see, we have the triangle similarity statement right there. So it's trying to say triangle CBA is similar to what triangle? Obviously, it's going to be some portion of FHG, GFH, whatever, but we have to make sure that the sides match up. So the one thing that we need to make sure of is, do we have a condition that helps us? So what we notice is for each triangle, I have three sides. So we're going to test if there is side, side, side similarity, since we're given three sides. So remember from the previous lesson, I said that you're going to match the biggest number of the big triangles to the biggest number of the smaller triangle, and so on. Whoops. So we're going to set up a proportion. So 84 is the biggest number of this triangle, which is going to match up with 14. So 84 over 14, is that equal to, let's go smallest to smallest, 48 over 8. Is that also equal to what's left? 72 over 12. So all three of these fractions have to be equal to each other for side, side, side to work. I obviously should have had a calculator with me, or, in class I would have been using you guys to help me out with this, but I think I can figure it out. 84 divided by 14 is 6. You guys all should know in your head, 48 divided by 8 is 6, times tables. And, another times table, 78 divided by 12 is 6. So therefore, all three of these fractions equal to each other. Therefore, these triangles are congruent. So now we have to write the similarity statement. Well, they told us that CB is first. So side CB right here, 48, went with the 8 side. So then we have GF, or some sort of form of GF. We'll double check it. And then let's check the last two. BA. BA is 72. And 72 went with 14. So yes, FH. So that is how you check for similarity and how you write the similarity statement. So this, remember, is the theorem or condition. This is the statement. All right, so first we said, okay, well, this is what we're going to check. Then we did our proportions. It worked. So here's our statement. All right, next example. Here we have this one. This one's a little bit different. So we notice that we do have indeed two sets of sides, but that's not enough. The next important thing is to check angles. Do we have any angle information? Kind of looks like we don't, right? Because I don't have anything written for angle measures, but I have a pair of intersecting lines. So intersecting lines mean these angles are congruent. So now I have two sides and an angle in between. So we're going to look for side, angle, side similarity. I forgot to write that one before. But you should have known it, right? You should have these notes already. This isn't our first rodeo here. All right, so let's check to see if we have side, angle, side. So in order for this to work, for similarity, we need to double check our sides. So which side goes with what? Well, let's do our big to small again. So 40 is the biggest number on this triangle right here. 16 for the other one. Is 40 sixteenths equal to 39 sixteenths? That should be easy. They both have the same denominator. 40 isn't equal to 39. Therefore, these are not similar. Now, I know some of you would have jumped the gun and said they're not similar because I don't have enough information, meaning I don't have a third side. Just make sure that you are not caught off guard with that. Please remember, intersecting lines do create vertical angles. All right, next. Here we have two triangles. We don't have any number information, but we are given information by drawing. So we can see that J is congruent to T, U is congruent to K. That's two angles that are congruent. So therefore, we have angle-angle similarity. So just by the markings, we already know that these are similar. So angle J, this is the first letter right here for our triangle similarity statement. Angle J is similar to angle T. K is similar to U. Therefore, L, which is this one right here, has to be similar to V. So that one is a super simple one, right? We see angle-angle similarity. We know that these two triangles have to be similar. So then it's just left for you to match up the angles for the statement. All right, final one. This is the one that gave us a little bit of trouble before. I remember before when we did this, it's been a while, I told you to go ahead and draw the two triangles out. So hopefully you can see the smaller triangle in here is within the bigger triangle. So I'm going to go ahead and write the vertices as well. So KBC, and this is also K, L, M. All right, so we know from K to B it's 16. Don't know anything about B to C. K to C is 25. K to L is this 88. K to M is going to be, wow, they're saying that's 107. Okay. Is 25 plus 107. So that is going to be, what is that, 132? All right, so as you can see right now with just numbers, we don't have enough information because we only have side. But you should notice there's two angle Ks. They have to be congruent. Therefore, we're going to check for, again, side, angle, side similarity, right? We have side, angle, side. So since you already have the angle, you need to check to see if the two sides are actually proportional. So biggest number on this side is 25. It's going to go with the 132. Next one is 16 over 88. Yeah, definitely not doing this one in my head. Sorry, I'm going to pull out my calculator. So instead of trying to do the fractions again, let's do it this way. Let's compare. Remember, you're going to do 132 times 16. We're going to butterfly it. 132, calculator. 132 times 16 is 2012. And then 88 times 25 is 2200. So obviously these two numbers are not congruent or not equal. So therefore these two triangles are not similar. Sorry, that's not writing as well. Not similar. Okay, so hopefully that has helped you out. I guess I'll do another frame here just to give you a quick rundown of what you're checking for. So again, you had angle similarity you could check, side similarity, side angle, which already works with angle. Side was the one I didn't talk about before. So remember, that's when you have two sides that are proportional. I know I'm drawing them as congruent. And the angle in between them are congruent as well. So these are the ones that are gonna work for you. Also, there's an angle side one, but again, you already had the two angles, so you don't need them. Hopefully this will help you out. If you haven't turned in your presentation, well, here you go. You have the theorems right here. You just have to draw it out. But hopefully this will help you out with the homework assignment or the daily work assignment, whatever you want to call it. Sorry if this was a little long, drawn out, and messy. I'm going to do it the same way again for the congruency one. But good luck. Let me know if you have any questions, and see you next time.